screen is visible?
Yes, sir.
Okay. So this is the first question. The type 1 system is given. Okay. One second. One second. Hmm. So the type 1 system is given and loop gain is k. Okay. This k is the constant. It has a 0 at s is equal to 1. Okay. One second. So it has 0 at s is equal to 1 and we have to find which of the following options are true for the closed loop unity feedback system. Okay. So first we'll write the transfer function, open loop transfer function, k into, this will be s is equal to 1 means s minus 1 divided by type 1 is there, so here s will be there, and here some dfs some function will be there, pole will be there. So this is the our open loop transfer function. So we should comment on this option. The closed loop system tracks a unit step with an undershoot. Is it correct? The closed loop system tracks a unit step input with an undershoot. Whether it will be correct or incorrect, can anyone tell? Okay, we'll see. Let's say I'm taking a simple pole, any pole. So k into s minus 1 divided by s into s plus 1. Okay, so this is g of s. What will be the step response for this unity feedback? So if we'll apply unity feedback, what will be the final transfer function? That will be 1 g by 1 plus g. Okay. So let's say g is equal to k into s minus 1 divided by s into s plus 1 or divided by 1 plus gs. 1 plus k s minus 1 divided by s into s plus 1. Okay. So s into s plus 1 will be cancelled. So k s minus 1 divided by s square plus s plus ks minus 1. Is it correct? So k into s minus 1 divided by s square plus k plus 1 s plus 1. So this will be our closed loop transfer function. Okay. So now what will be the step response if we will apply s square plus. Okay. Whether it will be correct or incorrect? Any guess? Closed loop system tracks a unit step with a undershoot. What will be the t tends to infinity? So s tends to 0. Let's say infinity I am checking. T tends to infinity, what will be the value? C of t. Okay. So limit s tends to 0, s into cs, correct? So what will be the value? Minus 1 by 1. 1 second. System goes to t tends to infinity means s tends to 0. Is it correct? Like all the calculation, can you verify? Anyone can comment here. See, first this open loop transfer function was given. I am just taking any simple pole s plus 1 in LHS. After that, we are converting into closed loop unity feedback, the closed loop unity feedback system. See, this is closed loop transfer function g by 1 plus g. Okay. So s square plus s plus k s minus 1. It is correct here. And this will be cancelled. So this is our closed loop transfer function. Now a step response we have to find. So into 1 by s, correct? So s tends to 0. This k is divided by, so it will be here, it will be 0 here. Is it minus 1? Wait, we'll see in MATLAB. 1 minute. Just I will type and we'll see the step response. The answer I have already. The answer for this question is like this is not correct. Okay, this option is not correct. We'll see in MATLAB once. This screen is visible.
Yes, sir. Yes.
Okay, so remember the question like what is the pole and zero? Like k I am assuming as one. Okay, let's say k is equal to one. Okay, k is equal to one. So transfer function will be s minus one divided by s into s plus one. This is our transfer function. Okay, open loop transfer function. Then I will convert it into the closed loop. So let's say I will comment this and okay. G1 is equal to s minus 1 s minus 1 divided by s into s plus 1. That one was the s s into s plus 1. Is it correct? So we have to find the
Yes, sir.
closed loop. Okay. So G2 will be equal to, let's say, G2 equal to G1 by 1 plus G1. G1 divided by 1 plus G1. So this is our closed loop transfer function. Now we can find the step response for this one. So simply a step G2. Let's see what we are getting. Where it is going. At t tends to infinity, it is going minus infinity. Is it correct? See.
Yes, sir. Yes, yes, sir.
So this is not a like underdamped kind of system. Like options it was there, no? There option is there with like the closed loop system tracks a unit step with undershoot. So we are seeing that the output is going to minus infinity. Okay, as we are increasing t tends to infinity. So we'll see like here we have done some mistake. I think we'll do the same thing manually. We'll get what we are getting. So gfs is equal to s minus 1 divided by s into s plus 1. Correct?
Sir, why we have taken a pole at -1, sir? It's not given in problem.
It is given. See, 0 at minus s is equal to 1.
Zero at, it's given, sir, but pole at you are taking pole also at -1.
Okay, okay, okay. So if nothing is given, like pole at minus 1 means already it will be unstable. Then, no, no. Pole at minus 1 I am taking means a stable system. Pole at 1, this is pole at minus 1. If it will be pole at plus 1, okay, then automatically it will be unstable. So let's derive the, for anything will be here, na? Like either left hand side or right hand side, it will give the same kind of response. Okay,
Okay, sir.
because of this zero it is happening, so we just convert it into the time domain. So what is happening? So that will be 1 divided by, first we will convert it into the closed loop transfer function. So s minus 1 divided by s square plus what will be the k is equal to 1 means that will be s square plus 2s plus 1. 2s plus 1. Is it correct?
Yes, sir. Yes. Only closed loop, sir.
Closed loop, CLTF.
Okay, sir. Yes. 12
So
plus
this
2
only k
plus.
will be 1. This
Okay,
is
sir.
correct
Okay.
only, no? S square plus s plus ks minus 1. So s square plus k plus 1 s minus, here it will be minus 1, no?
K
Right?
minus K, sir. K. We have to write K there.
Ks, okay, okay, ks minus k. Here only we have done the mistake. Okay. So s square plus 2s, here it will be minus 1. Correct?
Yes, sir.
Okay. And then one term will be there. Step response means 1 by s should be multiplied. That will be a step response, y of s. So this is closed loop transfer function, y of s will be, output will be 1 by s into s minus 1 divided by s square plus 2s plus 1. Okay. Now if we convert it into the time domain, that at t tends to infinity, it will go minus infinity. Okay. So let's apply that initial final value theorem will work here or not. That maybe if it will not work means this in this kind of system we cannot apply. This is 0 in the right hand side. We'll apply that theorem. Okay, limit s tends to 0, s into that one. Okay, so that what we are getting minus 1. It means that theorem is not applicable here. So if either pole or 0 will be in the right hand side, then that initial or final value theorem we can not apply. So if we convert it to the time domain, okay, so it's complex only. We have to do factorization and all. Then what will be the this one? S plus 1 whole square. Correct, no? So s minus 1 divided by s into s plus 1 whole square. Is it correct?
Yes, sir.
So this is y of s. So if we'll factorize in the time domain, then we'll get e to the minus e to the power some plus we'll get. Okay. So plus means when this kind of factor will come, minus e to the power plus t. So what it will do? It will go in minus infinity. This one factor, the negative sign will be there, and t will be positive. So if t is increasing to infinity, after some particular value, it will go to infinity. Is it clear? Should I factorize it, or you can do it by your own? This will be the reason. Okay. So one concept we have learned here, like if either pole or 0 will be in the RHS, okay, in that case this initial and final value theorem will not be applicable. Is it clear? Should we do the factorization for this one?
Please do, sir.
Okay,
Please
okay,
do, sir.
okay, okay. So I will write on the next page, s minus 1 divided by s into s plus 1 whole square. We can write it a by s, okay, plus b by s plus 1 plus c by s plus 1 whole square. But okay, s plus 1 whole square, this term is there, na? Okay, what it will be?
Yes, sir.
A to the what will be this inverse Laplace? See, this is decaying term. Okay, we'll
Yes, sir.
calculate the value also. See, we have three terms are there, na? This is one term, this is second term, this is third term. So this
Yes,
is
sir.
exponential decay. B e to the power minus t
Minus,
ut
yes, sir.
plus a ut. Okay,
Ut.
plus what will be this third term? C
T into e to the power of minus at, sir. Minus t.
minus t only will be there.
Yes,
Then
sir. S plus 1.
and then how it is going? Like minus is there means it will be 0 only, na?
Yes, sir. Yes, sir.
But how it is going? Some mistakes we are doing, I think. Somewhere some mistake is there, maybe.
Maybe that equation, sir.
Which one? Here?
Uh,
Once we'll verify in MATLAB. Wait. Here we have written correct s minus 1 divided by s into s plus 1, correct?
yes, sir. Yes, sir.
Then g2 is equal to g1 by 1 plus g1. This is closed loop transfer function. And we are taking a step of g2. So what we are getting? Where it is going minus infinity or some minus value thing. Minus infinity only. One second. It's minus infinity only it is going, I think. Sharply it is going, it means it will go at minus infinity only. Minus infinity it is going means there should be some exponential rise term. E to the power t should be there. You see the question one. 0 at s is equal to which of the following is true. So closed loop native feedback system. We have to apply native feedback k into s minus 1 sds. Some mistake we are doing. Otherwise, it should come some e to the power t term should come. Let's do it. What we are getting. So what will be the value of a? B. See, this will be constant, na? A. One constant value will be there. B will
Yes, sir.
decay. Like something mistake we are doing here. E, e to the power minus t. T 1 by s square e to the power minus t. So this will become 0. Okay, we'll see it later. So MATLAB we are getting, I will discuss in the next class. Okay, actually today I did not
Okay.
got time for class preparation, otherwise I should have come with the solution only. I was busy with
Okay,
some
sir. Okay.
personal work. So I will discuss this in next class. Okay, we'll go to the next question. So this is not correct. I will just tell the option. This is not correct. This is finite gain margin is also not correct. The closed loop system is minimum phase for. So minimum phase and non-minimum phase, anyone can tell what is the minimum and what is non-minimum? Anyone
There
want to
should
know?
not there should not be any uh, zeros and poles on right
In
side of the.
yes. So here, since one zero is in the right hand side, this is not a minimum phase. This system is non-minimum phase. So this is the correct option. Okay.
Okay, sir.
We have doubt on first one. So this I will discuss in the next class. Maybe some mistake we are doing here. I will just come with solution in next class. Okay.
Okay, sir. Sir, as one zero in right side, directly we can say that closed loop system has no minimum phase instead of doing all this.
Directly we can say based on this zero only.
Yes, sir.
No need to do anything. One zero will be
Yes,
there
sir.
means in closed loop also that zero will be in the right hand side only. So we
Yes,
have
sir. Yes,
derived
sir.
this na. This is closed loop.
Yes,
So
sir.
it will
There is
be
no
non.
need to do the first option, sir. Closed loop
Uh,
system tracks in.
this
Okay,
was
anyway.
not okay. Just I was trying to derive whether it will come or not. Okay, like it
Okay,
should.
sir.
It
Okay.
is going in infinity that we have changed in the MATLAB. So that should come here also. That was my plan.
Okay.
So okay,
Okay.
I will discuss that in the next class. Anyway, this option
Okay.
is incorrect. So this is the correct option. Okay. I'm moving to the next question. 1 second. Okay, so this is very easy question. The number of poles of the system. Can anyone tell how we can calculate from this body plot? What will be the
If
total
it is
number of
rising, it is rising zero. It is
one?
dis- declaring, then it is a pole, sir, like that.
Okay. So what? How many numbers of pole will be at origin? Number of pole at origin for this number of pole at origin. What it will indicate? A starting slope.
Yes, yes,
What is the
yes,
starting slope? So see here 40 dB, here 20 dB. It means this is one decade. From here to here it is one decade. So slope
yes.
will be
One server,
20
one server,
dB
20
per decade.
per decade minus, sir.
So see this also we should see. What will be the slope?
Yes, sir.
So S will be there. Only S will come. So
Yes,
transfer
sir.
function will be S here. Okay.
Yes, sir.
At this point we are getting one zero.
Yes,
10
sir.
to the power 0 means 1. So that will be
Yes,
1 plus s by 1. Okay.
yes, sir.
Again at 10 we are getting one pole. So 1
Yes, sir.
plus s by 10. This will be the transfer function.
Yes, sir. Yes.
So number of poles will be how much? 2. Correct? And number of 0
Yes,
will
sir.
be 1.
One.
Correct only? Okay. So the next question is, I will do that question here. The velocity error constant. Okay. So velocity error constant is kv. What is that? Limit s tends to
S
0,
tends to 0. S
s
into
gs.
G of S.
Correct? So, but
Yes,
we
sir.
don't know some k value will be there here. Some k value will be there here, but we don't know that k value. So, how to
Yes, sir.
calculate that k value? I have already explained one formula. So, corner
Yes, sir. Yes,
frequency
yes, sir.
greater than equal to the frequency where magnitude is known, all should be neglected. So, here we know the magnitude at this frequency. So whatever will be the corner frequency greater than 0 will be neglected. Okay. So directly we can write the equation 20 log k, okay, minus 20 log omega. So this k and s will be considered for k calculation, and this will be neglected. So 20 log k minus 20 log omega, 20 log omega, this should be equal to how much? 40. At omega is equal to 0.1. Correct? Is it clear how I have written this?
Please explain, sir. Forgotten.
See, at 0, at here we know the 10 to the power minus 1, we know the magnitude, 40 dB.
Yes,
This
yes, sir.
value we
Yes,
know.
sir. Yes,
So
sir.
for k value calculation, so corner frequency omega at m known.
Okay,
So
sir. Okay.
frequency at which the magnitude is known, if I know the magnitude here, okay. So greater than equal to frequency will be neglected from the this one GS by k calculation. So our
Okay, sir.
k for k only k by s will be there. So for this what will be the magnitude? 20 log k minus 20 log omega at omega is equal to 0.1.
Okay,
Okay.
sir. Okay.
So omega is equal to 0.1 greater than 1 is this is 1 pole 1, this is pole how much? 10. So these two poles I have neglected because omega is equal to 0.1. I know the magnitude. So whatever will be the pole or 0 greater than this will be neglected. This S is pole 0 which is less than 0.1. So this will be considered. Okay. 20 log k minus 20 log omega at omega is equal to 0.1. This should be equal to 40 dB. Correct? So
Okay, sir.
20 log k by omega, okay, is equal to 40. This omega we should put 0.1 because at 0. This is 10 to the power minus 1 which is equal to 0.1. So at this value only we have to calculate. So that will be 2. It will be 2. So k by 0.1, how much it will be? 10 to the power 2, 100. Correct?
Yes, sir.
100. So k will be equal to 10. Okay. K will be equal to 10. Now we can calculate the velocity constant. So that will be limit s tends to 0, s into 10, what is that? 1 plus s by 1, and below s 1 plus s by 10. 1 plus s by 1, and below it will be s 1 plus s by 10. Correct? So s
Yes,
will
sir.
cancel. And here 1 plus s, and here it will be. So this is 0. What will be the value? 10. Correct?
Yes, sir. 10 only.
This is the answer, correct answer. Velocity will be 10. Another method we can see here. See, sometimes Bode plot will be there. Na? If you draw the projection, okay. If you draw the projection for this line, that will cross 10 to the power 1. Correct? How I am saying that it will
Yes, sir. That line will cross zero line at where
10 to
it
the
will
power
cross
1.
at.
Correct? Na?
Yes, sir.
Because
Yes,
20
sir.
dB per decade here to here, again here to here 10 dB means it should cross 10 to the power 1. And that
Yes, sir.
formula shortcut I have given k is equal to what? Omega to the power n
10, sir.
minus 20 and d into 1. So n will be 1. Okay. So 10 to the power 1. Directly we can calculate this short trick. So k will be 10.
Yes, sir. Yes.
So this we should visualize. If this kind of plot will be there, no need to apply this equation. Directly we can draw and calculate. Is it clear to all up to now? Should I move to the next question?
Yes, sir.
Okay, okay, okay. So some data is given for a minimum phase. Minimum phase means pole and 0 are not in there in the right hand side. 2, 0 and 4 pole. The slope of log magnitude curve at omega is equal to infinity. It's easy question. Can anyone tell the answer? Number of pole are 4 and number of zeros are 2. So what will be the slope at infinity? Can anyone tell? See, any pole, how much it will contribute? Slope?
20 decibels per decade, sir.
Okay. So 4 poles means how much it will contribute?
80, sir.
Minus 80, correct?
Okay, sir.
And 20,
Yes, sir. Yes, sir.
how much it will contribute? 20.
40 decibels
Plus
plus
40.
40.
So at infinity, which will be dominant? 0 will be dominant.
Poles will be dominant,
Poles
sir.
will be dominant. So what will be the final slope? That will be minus
Minus 40, sir.
40 dB per decade. Easy only?
Yes, sir. Yes, sir. Yes, yes, sir.
Okay. Okay. Similarly, this is the next question. So here 2, 0 and 4 poles are there. Is it reverse or same? It is
Reverse, sir.
non-minimum.
It's
It
yes,
is
sir.
minimum phase and it is non-minimum phase. Okay.
Yes, sir. Yes,
So
yes.
2, 0 and 4 pole. What will be the answer? Same question.
It's
Eh,
40 decibels positive, sir.
Positive or negative? How
Negative,
positive?
negative, negative, sir. Negative.
Negative
Positive,
only.
positive,
Either
negative.
minimum or non-minimum, the magnitude plot will not be affected, I think.
Yes, sir.
Correct?
Yes, yes. Yes, sir.
So here also it will be same.
Yes, sir.
Like 2 zeros are there, so we can apply 2 minus 4 into 20. How
20
much?
decibels per decade.
Minus 40
Minus.
dB per decade. Correct?
Yes,
Okay.
sir.
Okay. Okay. Move to the next question. So here for a minimum phase system, 2 zeros and 4 pole. This is minimum phase system. Okay. 2 zeros are there and 4 poles are there. At omega is equal to infinity, what will be the angle contribution? Can anyone tell the answer?
It's minus 180, sir.
How?
Two,
2 0. How much
yes,
it will
sir. Two
contribute?
zero, two zeros will contribute plus 180, 1990 plus 180.
Plus 180 and 4 pole will contribute
360 degrees.
minus 360. Correct?
This chart this.
No, no.
Yes, sir. Yes.
Is it correct? One pole, how much? Minus 90.
Yes, sir.
So
Minus
what?
90. It is taken to numerator. It will be minus 360.
Okay, okay. So it will be total angle contribution will be minus 180. Correct one. Is it clear to all?
This one. Teachide.
Clear up to now?
Yes, sir. Yes, sir.
Okay, okay. So moving to the next question. Okay. So some model plot data is given. Okay. We have to find the phase margin of the system. How we can find? Any guess? What should be the step? How we can find the phase margin? Here only magnitude plot. So what should be the step? From body plot we have to find the phase margin. What should be the step? Can anyone tell how we should proceed? First we need the transfer function. This is correct. Can anyone tell how we should approach for this question? See, body plot is given. Okay. So we need the transfer function. Then only at some like something will be there. Omega GC will be there. This is omega GC somewhere. At this, we'll calculate the phase and 180 degree plus GS at omega GC. That will be the phase margin. Is it correct?
Yes, sir. Yes, sir.
So we'll calculate one by one. So as starting some constant is there. First pole we are at zero, no pole is there. Correct? So this is not a type 1 system. Just going to write the GFS. GFS is equal to at 10 to the power 0 means 1. 1 one pole is there. So 1 plus s by 1, correct? Again, what is this? Okay,
It two, sir, two.
okay, at 2. So is it a decade like 10 to the power 0?
Decay, sir, decay.
10 to the power 0 is 1, 1 to 2. So it's a 1 decade, they are saying it's a 1 decade. Okay. So minus 20, it is minus 20 here and it is minus 40 here means it's a 1 decade. 10 times it is going minus 40. Okay. So this is a log sheet. So s by 2, 1 plus s by 2, correct? This one. Again here it will be 3,
Yes, sir, yes, sir.
1 plus s by 3, correct? And here it
Yes.
is 4. So is it correct? 1,
Uh,
2,
yes, sir.
4 only.
Yes, sir, yes, sir. Two,
But
three,
here
four, sir,
here it
four.
is 0, not
Zero, sir,
4,
zero. Zero.
because it is going here. So 1
Yes, sir.
plus s by 4
Four.
k into this one. So this will be our transfer function, correct? Now we have to calculate the value of the k. What will be the k value? So see here, at omega is equal to 1, we know the value. Okay, at omega is equal to 1, we know the value. So the poles greater equal to 1 will be neglected. Okay. So this and this all will be neglected. So what will be the 20 log k, correct?
Sir, sir, please explain this point, sir.
See, and that while calculation of k value. So this is our
Okay, sir.
transfer function. Okay.
Okay, sir.
So corner frequency greater than equal to omega. This is
Okay.
omega value where we know the magnitude. Okay. So at some particular value we know the magnitude. So all the corner frequency greater than and equal to omega from the transfer function will be neglected while calculating the k value. Okay. So 10 to the power 0 we know the magnitude. At this frequency I know the magnitude, that is 18.1. Correct? So all the corner
Yes,
frequency,
sir.
this and this terms I will neglect while calculating the k value. See, let's say
Okay,
if
sir.
I know the magnitude at here, in Bode plot, if let's say if I know the magnitude at this point, so in that case I should include this while calculation of k value. Okay,
Okay, sir. Okay.
like what will happen in that case? In that case, let's say I'm just saying for example, let's say here I know the magnitude at this point. Okay, let's say some m magnitude is there. So how I will calculate magnitude in this case? This case, this should not be neglected because greater than equal to 2 should be neglected. This is 2. Okay. So what will be the equation in that case? 20 log k minus 20 log. And for this one, it will be under root 1 plus omega square. Correct? This should be equal
Yes,
to
sir.
m.
Yes, sir.
Is it clear? So
Yes, yes, sir.
where we know the magnitude, okay, corner frequency greater than and equal to that point should be neglected. Clear?
Okay, sir. Okay, sir.
So
Okay.
here we know the magnitude as s is equal to 1. Okay.
Yes, sir. Yes, sir.
So s is equal to 1, we know the magnitude. So all should be neglected and then 20 log k only will come. This should be equal to how much? 18.1. Correct?
Yes, sir.
Okay. So now we can find the value. Log k will be equal to how much? 18.1 divided by 20, and k will be 10 to the power 18.1 divided by 20. How much it will be? 10 to the power 18.1 divided by 20. So I am getting 8.035. Is it correct? Approx 8 we can say.
Yes, sir.
Okay. So
Yes, sir. Correct, sir.
okay. So now I will just write the transfer function. So 8 into how much? 1 plus s by 4. 4 1 plus s by 1, 1 plus s by 2, 1 plus s by 3. This is our g of s. We can simplify it. So s plus 1, s plus 2, s plus 3. Then 6 will go at top and 4 will go at bottom. So 6 into 2, 12. So 12 s plus 4 divided by s plus 1, s plus 2 and s plus 3. Is it correct? Clear up to now?
Yes, sir. Clear, sir.
Okay. So now what we have to do? We have to calculate the phase margin. Correct? Clear. So the phase margin of the system in degree. We know the plot. But what is the gain crossover frequency? This only, correct? What will be this value? So we can calculate this. What is this? Can we calculate this value from this plot only? Is it possible? Can you tell? See, this slope is how much? Minus 60 dB per decade, correct?
Yes, sir.
So slope from here to here also should be same. So let's say y2 minus y1 by x2 minus x1. So y2 is 0. Y2 is 0. But we don't know this value. Correct, no? So one by one we should calculate this value. Then only it is possible. Y2 minus. Okay. So let's say this is 18.1 dB. Okay. What will be this value? 10 dB it will decay. Correct? 20 dB. 1 second. So what will be the value here?
Yes, sir. Minus 1.9, sir.
Minus 1.9, but it is plus 1 in here. Something. It should be above 10. Huh?
Yes, sir.
Let's say not like that. Y2 minus y1, I will calculate one by one. Y2 minus y1 divided by x2 minus x1 is equal to minus 20, correct? So y2 minus y1, this one, this value, this is y2. So y2 minus 18 divided by log 2 minus log 1. This should be equal to minus 20, correct? What will be the y2 value here? So minus, is it correct now? See, I know the magnitude of this point. I want the magnitude at this point. So slope equation is y2 minus y1, y2 minus 18.1 divided by, this is log 2. Logarithmic we should take. So log 2 minus log 1 is equal to minus 20, correct? So y2 will be minus 20 into log 2 minus log 1 plus 18.1. So minus 20 into log 2 minus log. We'll see the Bode plot also. First we'll calculate manually, then we'll see the MATLAB Bode plot. Both will verify. Log 2 minus log 1 into minus 20. Okay, correct? So it is coming minus 6.02 plus 18.1. So I am getting 12.07 here. I am getting the magnitude for this one 12.07. Okay, correct? Similarly, we can apply for this one, for this point. So that equation will be, I'll write in the next page. So y2 minus 12.07, y2 minus 12.07 divided by, this is log 3 minus log 2. So log 3 minus log 2 is equal to how much? This is minus 20 only, minus 20 So minus 20 dB per decade. Okay, here it is minus 40 dB per decade it is showing. One second. So minus 20 and minus 20 again one pole came, no? So it will be minus 40. So we should put here minus 40. Should be equal to minus 40. Is it clear up to now? So y2 value we can calculate. Y2 is equal to minus 40 into log 3 minus log 2 plus 12.07. Is it clear up to now? Log 3 minus log 2. So minus 40 into log 3 minus log 2 plus 12.07. 5.026 I am getting. 5.026. So this value magnitude I got. Now I want the omega at this point at 0. Okay, this is magnitude 0. This magnitude is how much? One second. 5.026. So this is 5.026. This value 5.026. This is 0 dB. This is this much dB. So we know the slope also minus 60 dB per decade. So we have to calculate value from here. So y2 minus y1 0 minus 5.026 divided by log omega minus log how much? 3. This point is 3. 1, 2, 3. So this point is 3. Log omega minus log 3. This should be equal to how much? Minus 60. So from here we can get the gain crossover frequency. Is it clear up to now? From this equation, what will be the value of omega? That will be omega GC.
Okay, sir. Okay.
Is it clear, this explanation?
Yes, sir.
Okay, okay. So minus t by this one, so minus 5.026 minus 5.026 divided by minus 60 plus log 3 plus log 3. Yes, this we are getting 0.56088. So log omega 0.56088 and 10 to the power, if you will do 10 to the power 0.56088, I am getting 3.638. Omega is equal to 3.638. Okay. Based on this, we can calculate the phase margin also. So I'm going to use the MATLAB. We'll see whether this omega is correct or not. Okay. Omega is equal to 3.638. Okay. So our transfer function is 12 into s plus 4 divided by s plus 1, s plus 2, s plus 3. Okay. So 12 into s plus 4. 12 into s, one second, capital S and s plus 4 divided by s plus 1, s plus 2, s plus 3. This is s plus 1. And I'm copying this. One second. One second. Okay, I'll type on s plus 1 s plus 1 into s plus 2 into s plus 3. Is it correct? 12 into s plus 4 divided by s plus 1, s plus 2, s plus 3. So we'll calculate the margin for this one. Margin G1. Something is mistake is there. 12 into s plus 4. Let's see. Hmm? Phase margin we are getting minus 180 degree at 1 radian per second. 1 second. I think some mistake is there. S into 12 into s plus 4, s plus 1, s plus 2, s plus 3. 12 into s plus 4. Okay, here two things I have kept now. Control R. Now, see, we are getting this 3.39, 38.8 degree, right? So, how much we have calculated? Something 3.638 we are getting, right? So, some calculation like decimal we are leaving now. So, due to that we are getting this error. So, 3.638 I got, but here it was 3.39, right? How much I have calculated? 3.638. So, some because decimal if we'll do here and there in log, we will not consider all the decimal values, then we'll get the wrong answer. Is it clear?
Yes, sir.
Okay. So based on this, we can calculate the phase margin also. Like phase margin, how we can calculate? Just we have to put the value of omega GC and we have to calculate the angle of this and then 180 degree will add, then we'll get the value of that. So I have calculated omega GC with the Bode plot. With this one also we can calculate the omega GC. We have to make magnitude equal to 1. But if we make magnitude equal to 1 for this one, that will be a very complicated transfer function, like complicated equation. Let's see what will be the equation if we make magnitude equal to 1. So 12 into under root omega square plus 16 divided by omega square plus 1 into omega square plus 4 into omega square plus 9, correct? This should be equal to 1.
Yes, sir.
Is it correct?
Yes, sir. Yes.
So if we'll assume omega square is equal to x, okay? I'm assuming omega square is equal to x and squaring both sides. So 144, okay, x plus 16, correct, is equal to x plus 1, x plus 4, x plus 9. Is it correct?
Yes, sir.
Okay. So now, I'll take it in next page. So this equation, if you solve, we'll find the same value. So how much it will be? 144x plus this value, you can tell. So here it will be x square plus 5x plus 4, correct? X plus 9 into x cube plus 5x square plus 4x plus 9x square plus 45x plus 36. Is it correct?
Yes,
Two,
sir.
this is 2304 we are getting. So equation will be x cube plus 9x square. How much? 4x plus 45x. 48x, correct? No, no. 49x, na?
Yes, sir. 49x.
49x minus 144x, okay, plus 36 minus
2304.
2304. This will be the cubic equation. 0. Correct? So what will be this term? 49 minus 144 minus 95. X cube plus 9x square minus 95x plus this will be 36 minus 2304. 36 minus 2304 minus 2268. This will be minus in your final exam this scientific calculator is allowed or not?
Not allowed, sir. Only we have
So
to do on the computer screen itself.
that gate
Only.
calculator will be there.
Yes, sir. Yes, that type of calculator will be there, sir.
Okay, so in that cubic equation we cannot solve.
This option will not be there, sir.
Okay, okay. So like this kind of equation we can solve with the scientific calculator directly, but their option will be not be. So only one option is there. Like if some options are given, from that option, this kind of,
We have,
let's say they are asking omega GC. Okay,
oh, yes, yes,
what will
yes,
be the
sir.
omega GC? So we'll find this equation. Okay, after finding this equation, omega x square is what? Omega gc. So we'll put that value in this equation, and whatever will be result in 0, that option you should tick. Okay. So it will be objective kind of exam only in semester.
Yes, sir. Yes, sir. Objective only,
Okay,
sir.
okay. So this process only you should follow.
So,
If
some fill in the dash type also will be given, sir.
okay, but that kind of question, this kind of question they will not frame, I think. If this kind of
Okay, sir.
question will be there, then surely they will give the option. Okay.
Okay, sir. Okay.
Otherwise, easy will be there. Let's say sometime we are putting 1, 0 and we are guessing one or root of the cubic equation. So if fill in the blanks will be there, then one root we will guess, and basic method, factorization method we can use to solve it. So let's solve it, what we are getting. So I'm going to solve it. 1 second. 1, 9 minus 95 and minus 226. So one value I'm getting 12.65. 12.658. X1 value, I'm getting this one. Another value minus another two value are complex, so that will not be considered. So what will the square root for this one? 12.658 under root 12.658. I'm getting 3.55. X is equal to 3.55. Almost same we are getting, correct?
Yes, sir.
Here,
Yes, sir.
here also with directly Bode plot I have calculated. So almost 3 point. The range they will give. If fill in the blanks will be there. Let's say here this Bode plot was there now. So like this they will give the question, and this will be given. Then no need to solve by this cubic equation. Okay. No need to solve this cubic. Directly we can see the Bode plot, and we can find the zero crossing magnitude frequency. Okay. So this explanation is clear to all. How I have calculated both the method. Is it clear?
Yes, sir. Yes, sir.
Okay. So two things we can do. One, with Bode plot, we can find the gain crossover frequency. Another way, from transfer function, we can find the gain crossover frequency. Then, like, okay, so if we know the frequency, then phase margin, we know what is the phase margin? 180 plus angle GJ omega at omega GC. That will be the phase margin. So, should we calculate this one also? Phase margin? Okay, wait. I'll put this in the next. So, this is our transfer function, and omega GC we got almost 3.5, right?
Yes, sir.
So at omega is equal to 3.5, we have to find the angle. So first I'm finding angle. Angle will be tan inverse omega by 4 minus tan inverse omega minus tan inverse omega by 2 minus tan inverse omega by 3. This will be angle at, so we'll put the value this one. So tan inverse 3.5 by 4 minus tan inverse 3.5 minus tan inverse 3.5 by 2 minus tan inverse 3.5 by 3. So how much will be the angle? I am also calculating. You can calculate tan inverse 3.5 by 4 minus tan inverse 3.5 by 1. 1 second. Minus tan inverse 3.5 by 2 minus tan inverse 3.5 by 2 minus tan inverse 3.5 by 3. How much you are getting? Anyone got the answer? How to be the angle for this one? So I am getting minus 183.69. Minus 183.69. Okay. So phase margin negative we are getting. Some mistake. Any mistake is there? Minus 183 plus 180. A mistake is there. We'll see the MATLAB answer. 38.8 we should get na. 38.8 final answer. So it should come less than 1 minus 180. Correct? Any mistake is there in this one? Anyone rectify? 12 into s plus 4 divided by s plus 1, s plus 2, s plus 3. Omega, omega by 2, omega by 3, then omega by 4. Can anyone reply? Hello?
Sir,
Any mistake is there in this one? How much we are getting? Is it correct? This minus
not
180. This
not
is
calculated, sir. Actually.
okay. Okay, you can also try it because we are getting some different value. The answer is different, not this. Phase margin is like 34.8 degree. Okay, phase margin is equal to 34.8 degree. So this is our transfer function, and okay, let's say we got in Bode MATLAB how much? 38.8 degree. It means here if you see the angle at that point should come some less than 180. You see the data tip. So let's see what is the angle here. Angle we are getting minus 142. So minus 142 plus 180 it will come. I think some mistake is there in that calculation. We'll use this 3.39 only. Okay. If we use 3.39, then see what we are getting. Omega is equal to 3.39. Okay. So phi will be tan inverse 3.39 by 4 minus tan inverse 3.39 minus tan inverse 3.39 by 2 minus tan inverse 3.39 by 3. Correct? So tan inverse 3.39 by 4 minus tan inverse 3.39 minus tan inverse 3.5 is minus 142. Okay, so that was also correct. I think some mistake is I have done here. This is how much we are getting minus 142. Correct? This what I have written is correct. 3.5 by this equation is correct now. Can you reply?
Yes, sir, it's correct. The
So
calculation is wrong.
okay. Maybe I have done wrong calculation in calculator. So minus 142 we are getting correct. So minus 142 plus 180. How much we are getting? minus 142 plus 180. Almost 38 we are getting. Okay, 38 degree. So some error is there because this 3.5 is maybe not correct. Some 3.39 if we put, then we'll get this one. But we'll see how much we are getting in this one. 38 only we are getting, na? See. So I think 3.5 is correct only. 3.45. We will see here 3.39. It means 3.4. And what we have calculated is 3.5. Correct. So this is correct only. Almost 38 degree phase margin. Is it clear to all? Hello.
Sir, clear.
Okay. Okay. So same. We'll see the next question. One second. So the same system, what we'll do the cascading of the same system. So system was 12 s plus 4 divided by s plus 1, s plus 2, s plus 3. Okay. Cascading with minus s plus 4. Okay. Now the open loop steady state unit response. Steady state unit response. What will be the value? So 12 into, can we calculate this by that initial and final value theorem? Is it possible? Will that work here? What will be the transfer function? 12 into s plus 4 plus s 4 minus, so 16 minus s square, correct? Divided by s plus 1, s plus 2, s plus 3. Step input. So I am going to calculate steady state value. Limit. I think this will not be correct. S tends to 0. Okay. And s into 1 by s. Correct. So that will be 12 into 16 divided by 6. 32. Is it correct? I think it is correct only. We'll see in the MATLAB. Okay. One second. We'll see in the MATLAB. So we are getting 32 final value. What will be the final value? Steady state output means final value theorem I have applied. T tends to infinity means S tends to 0 SFS. We know this formula, correct? So 12 into 16 divided by 6, 6 into 2, 16 into 2, 32. So same thing we'll see in the MATLAB what we are getting. So here only S plus 4 into minus S plus 4, correct? Minus S plus 4. And we'll see the step response. Step G2, G1. How much we are getting? One second. 32 only we are getting, I think. Correct? See, 32 we are correct, na?
Yes, sir, correct, sir.
So I think something I have told, like if it is like 0, here one 0 is there, na? 0 is there in the right hand side, correct? So the final value theorem is applicable here. Some question was there, na? There I have commented like if this will be there, then that will not work. Maybe that is not true because here, like if pole will be there in the right hand side, if pole will be there in RHS, that system will be unstable. Then initial final value theorem will not work there. Okay, but here 0 in the right hand side, correct? But in that case, the final value theorem is working. So here we have seen the amplitude is 32. Is it clear? Should I move to the
Yes,
next question?
sir.
Okay, okay.
Yes, sir. Yes.
Going to the next question. So, if system has right half 0, the same C1 as above, since the system had right half 0, it experienced an undershoot. Okay, okay. So we have seen the undershoot here now. Because of right half 0 only, this undershoot coming at initial, correct? So we'll see how much we are getting. 1 second. We can do it in step info. So it will show all the parameter. Step info G1 if I will do. See, something came here. So undershoot how much we are getting? 3.4471, correct? Is it visible? I'll just copy this and paste in the second. Is it visible, this values? Can you reply? Now it is visible.
Now it's okay, sir. Now it's okay.
So undershoot. So for MATLAB command is there for this one, a step info. Like for a step response, we are writing a step G1, a step G. We want information all the parameters. So a step info. Okay. So we'll see in the command window this value will come. So undershoot we are seeing here in the this kind of waveform was coming. Starting at it is going like this, then it is coming and settling. This is happening because of the right half 0. It is experience and undershoot, the absolute value of the peak undershoot. So this how much we are getting? 3.4471. But how we can calculate manually? See, this is not a second order system. Okay, it's not possible to calculate manually, I think. We have to minimize into the second order system, then only we can calculate. Otherwise, it is very difficult, I think, manually calculation. Maybe this kind of question will be given in the assignment. Weekly assignment, you will find this kind of question, not in the in semester exam. Is it clear up to now? All of you have MATLAB, installed the MATLAB in your system? Hello? Can anyone reply? Is it clear up to now?
Yes, sir.
Okay. So okay. This is the last question. So many options are given here. MSQ type question. Which statements are true out of 4? Okay. So the body represents a non-minimum phase system. Is it correct? Is it correct? Non-minimum.
No, sir. No, it's minimum, sir.
How?
Because it's a constant.
But phase angle
Man,
we should
man.
see, na? Phase angle.
Okay, sir. Okay, okay.
Phase angle is going 360 to 180.
Okay,
Correct?
sir.
At
Okay.
t tends to infinity, phase angle is going 360 to 180. Correct? When it is possible only when this will be a non-minimum kind of system, then only it is possible. The magnitude
Okay.
is constant means it will be some s plus a divided by s plus b, some same thing will be there, like s plus the same point pole and 0 will be there, I think. Then what will be the magnitude? That will be constant one, correct?
Yes, sir.
Let's say
Yes,
this
sir.
kind of transfer function will be there, magnitude will be always constant. Okay, but if both will be positive, what will be the angle? angle omega is equal to 0, what will happen? If 1 will be negative, what will happen? Let's say minus s plus a divided by s plus a, correct? At omega is equal to 0, what will be the angle? That will be 0 or 360 degree, correct?
Yes, sir. Yes, sir. Yes.
And at infinity, what will be the angle? This will be how much?
Minus. Yes.
So it should go from 3
Minus.
at s is equal to 0. What will be the angle? Tan inverse. So minus omega minus s plus a. Okay. S is equal to j omega. I am putting first minus j omega plus a. Okay. Divided by j omega plus a. Correct. So what will be
Yes,
the
sir.
angle for this one? Minus j omega plus a. Correct.
Yes,
So
sir.
180 degree minus, that will be 180 degree minus tan inverse omega by a, correct? For this
Yes, sir.
part
Yes.
angle. And this will be minus tan inverse omega by a. So omega is equal to 0. One second. Correct only. So what is omega is equal to infinity? Infinity it will be minus 180 degree, correct? Omega is equal to infinity, it will be minus 180 degree. But here, okay, minus 80, 180 same. And omega is equal to 0, we are getting plus 180. This is some here mistake is there. 180 degree. This is the angle. Okay. Any mistake is there? So this will be the non-minimum phase. See, 360 to 180 degree it is coming. Like this we should analyze. Okay. So let's plot a Bode plot for minus s plus 1, s plus 1. Okay, we'll see the Bode plot in the MATLAB. Minus s plus 1 divided by s plus 1. G1 is equal to, one second, minus s plus 1 divided by s plus 1. Correct? And then margin G1. T. So it should come like that only, then only that option will be correct. See what is happening? Is it visible? Hello?
Yes, sir. Yes, sir. It's visible, sir.
So at 0, it is going 360 degree. At infinity, it is coming 180 degree. Correct? So the function is minus s plus 1 divided by s plus 1. At 0, it is 360 degree. So minus s plus 1, you'll see how it is 360 at 0. At 0, it should be 0 only. So minus s plus 1 divided by s plus 1. Angle will be for this one minus s. Okay, I have done mistake. See, here I have done mistake. This is imaginary, na? This is real. So, one second. The angle for numerator will be minus j omega, 1 minus j omega. So 1 minus j omega, correct? And 1 plus j omega for the that one. So minus tan inverse omega by 1, it will be for numerator, correct? And minus tan inverse omega by 1. So at 0, it will be 0, correct? At 0, omega is equal to 0, it will be 0. So 0 or 360, it is same. And omega is equal to infinity, it will be minus 180. So minus 180 or plus 180, it is same. Is it clear now? Hello? This will be the phi.
Yes, sir. Yes, sir.
So that's why this
Yes,
this
sir.
op
Yes.
this option is correct, non-minimum phase system. And this kind of system represents a all-pass filter. Okay. So these two options are correct, and these are not a minimum phase system, and phase margin of system is 30 degree. No, what you have seen the phase margin here. 1 second. Phase margin how much? 0 we are getting at infinity radian per second. Okay. So is it clear up to now? This was the last question. If any doubt is there, you can ask. Hello.
No,
Any?
sir. Thank you, sir. Thank you, sir. No, sir.
Okay. So thank you all. Next Sunday I will come with more question, more detailed analysis. I will come. Okay. Maybe I will take more than 1 hour. I will summarize many like last sessions. Okay. And whatever the question I have not solved today, like that one question was there, so I will come with that solution also. Okay. So thank you all. We'll meet on the next Sunday.
Okay, sir. Thank you, sir. Thank you.
Okay.